So the first thing that we are going to discuss is all about atoms. So what are atoms? Atoms defines matter and makes up everything in the universe. With that being said, it is considered as the basic unit of matter. Similar to the human body, which is composed of cells as the basic unit of our body, matter's basic unit is atoms. So atoms have mass and are indivisible. However, even though they have mass, they are not visible to the naked eye as they are very, very, very small. Similar to humans, atoms have their own identities. So how can we identify an atom? So in this image, it shows how atoms are identified in the periodic table. So X is the chemical symbol, A is atomic mass, which is protons plus neutrons, and Z is the atomic number. The atomic number gives the identity of the atom. And this atomic number is equal to the number of protons and number of electrons of the atom at ground state. So for example, 1H1 and 4HE2 are different and have different identities because they have different atomic numbers and that they have different number of protons and electrons. That is it.
The most broadly accepted theory for the origin and evolution of our universe is the Big Bang theory, in which the universe, along with time, space, and matter, started off as a singularity that is extremely hot and a very dense point. The Big Bang theory was not an explosion in space, as the theory's name might suggest. Instead, it was the immediate expansion of the universe, which is called inflation. As the universe expanded, the temperature cooled down enough for protons and neutrons to combine and form nucleus. The combination is called nucleosynthesis, and the first nucleosynthesis occurred within the first 3 minutes after the expansion of the universe, and after hundreds and thousands of years later, when the temperature cooled down enough, nuclei combined with electrons to form atoms. The first atom formed is the lightest element, hydrogen, which has 1 proton and 1 neutron. Afterwards, the second element that was formed is helium. The fusion of hydrogen atoms with helium signals the birth of a star. A star is formed when atoms of light elements undergo enough pressure for its nuclei to undergo fusion. All stars are the result of balance of forces, and as long as the fusion is equal, all stars will be stable and exist.
Elements, atoms, and history. In 450 BC, Empedocles asserted that all things are composed of 4 primal elements: earth, air, fire, and water. In 400 BC, Democritus proposed that all matter is made of atoms. In 1808, John Dalton formulated the atomic theory and proposed the law of multiple proportions. In 1895, Wilhelm Röntgen discovered X-ray. In 1897, J.J. Thomson discovered electrons. In 1904, Joseph John Thomson suggested the plum pudding model of the atom, where negative elements disperse in positive structure. In 1913, Niels Bohr proposed an atomic model that shows electrons more in concentric orbit around the nucleus. And in 1919, Ernest Rutherford discovered the protons.
The ancient definition of matter started on 450 before Christ era with Empedocles. He stated that matter was composed of 4 elements: fire, air, water, and earth elements. On 400 before Christ era, according to Democritus, matter is made up of tiny particles called atoms. On 380 to 320 before Christ era, Aristotle stated that matter was continuous. And in 1661, Robert Boyle hypothesized that matter consisted of corpuscles and clusters of corpuscles in motion.
To let you know more about atoms, atoms is the smallest unit of matter which contains all the properties of an element. It is made up of the nucleus where protons and neutrons are found, protons, which are the positively charged particles, neutrons that are electrically neutral, electron cloud that is described where electrons are going around the nucleus, and lastly, the electron, which are the negatively charged particles.
The people who contributed in developing our periodic tables are Anton Lavoisier, Jan Jacob Berzelius, Johann Dobereiner, John Newland Slaughter-Meyer, who arranged the elements based on their periodicity, and also Dimitri Mendeleev, who arranged the elements with similar properties, and also the father of periodic table. Way back before, the total number of natural elements in our periodic table is only 92, and because there is a gap or empty space in the periodic table, the scientists came up with an idea in creating an element or the synthetic elements that will fill up those gaps, and the total number of those elements are 26, and now the total number of our elements in our periodic table is 118.
Arrangement of the elements in the periodic table. Let me show you this. If you notice this line in the periodic table, this divides the properties of the elements in this periodic table. These properties are metals, non-metals, and metalloids. Characteristics of metals are malleable, ductile, good conductor of heat and electricity, and most of it are solid. Next is the non-metals. The characteristics of it are brittle, poor conductors of heat and electricity, and it can be defined as solid, liquid, or gas. Last one is the metalloids. It has the properties of both metals and non-metals. You can classify periods if it is from left to right. And you can classify groups if it is from the bottom to top. So this group are alkali metals. This one is alkaline earth metals, and these are the transition metals. Yes, the transition metals. And this is halogens. Last group is called as the noble gases. And that's all.